Hey guys, welcome back to the next video. In this video, we are going to scale up our WebLogic pods. So right now you can see that we have two managed servers running, and these two managed servers are represented in Kubernetes as pods. So you have the managed server 1 pod, managed server 2 pod running right now. So what we're going to do is we're going to scale up to our maximum of the available cluster. So the available cluster is 5 servers under this cluster. Now, can you go beyond that? Well, you can go beyond the 5 clusters and you can create six or seven pods as well. There's no limit for the number of pods you can create on Kubernetes. But the problem is what's the point of creating such or that many pods, because your WebLogic configuration only says 5 and there's no point beyond that. So you can actually have them created, but then it won't have any reason or a purpose to exist. It's just like occupying, or it is just taking system resources or hogging onto system resources. That's the right word. So what I'm gonna do is I'm gonna bring these servers all back up. So currently it is in the shutdown state. It's not assigned to any nodes as a machine over here. So that's not needed for you to bring it up. And each servers are gonna have individual IP address because each servers are gonna brought out by each pods under it. So 8001 should still work fine. The other thing which you should see as a difference is that kube control gets service -a. Sorry, I've just started it. The machine's virtual machine was shut down. You just have to start it back again. So that's why. Currently my bill is, I guess, I'm charged $16, I guess. $16 to $19 still is within my threshold. So you can see that in the cost and upgrade. So you can see $19. So within my threshold, I'm just expecting by the end of this course, it should be around like $25 of a price. So I keep keeping it in the limit because I shut it down once I create all my videos. So you should do the same. That should compress the amount of dollars which is getting increased as we are being charged per hour. One more thing to notice when you increase the scale of the servers is basically having this cluster members increased as well. So kube control describe service name namespace name. So here currently you see 2 endpoints. So once you have these servers spinned up, you should automatically see multiple endpoints joining over here, because this is all listening for this selector, which is cluster 1. So once your new pods are created for managed server 3, 4, 5, and all these pods will be having the same selector. So the selector will automatically, detect these other servers which is getting spinned up. And once that is coming into the ready state, then you will actually see that adding here as part of endpoint. But it needs to come into the ready state to do that. Until then, you will not actually have those servers participating. So just to give you that understanding, right? So what I'll do is I'll log into that machine as well. I'll log into this machine 172.31. I cannot log into that machine. I'm sorry, because I will have to use the. So normally SSH wouldn't work because it is all SSH is mostly on passwords. So in this scenario, we are not using passwords. We're using the key file, right? So I'll not be able to do SSH from one system to another system. So I may have to restructure this. I have to create another service server over here. Now in this server, what I'm going to do is I'm going to run a command, which is going to be creating a pod. Okay, this is the one. So this is going to sleep for every single second. So the font size is too small, isn't it? So what it is going to do is like it's going to run a load generator. That's the name of this pod. It's going to remove this pod once it completes, and it's going to run busybox image, and it is going to be run on the namespace as this namespace, like what we have configured so far. So that same namespace it's going to use to run. Let me increase the font size. Yeah, so it's going to use to run the same namespace. If I'm going to run this outside this namespace or a different namespace, it's like by default goes to the default namespace, then this IP address and port number will not be accessible. So instead of IP address, I'm going to use the service name. So you have the option of using the service name. So you see this cluster service, right? So currently, when I run this, right, so using the service name, as I said you previously, the service name is quite useful because IP address will change, but service names wouldn't change because you have hard coded the service names in your configuration while you created the services, right? So your service name would be the same, it wouldn't change. And what's going to happen here is that the the port number is the same. Again, it's hard coded, and it's going to access this my app var file and index.jsp. The beautiful thing about accessing this page is that you're going to see which WebLogic instance you are coming through. So I can use this browser and refresh this, but again, I have to do manually. But this is going to do a while loop every second. So which means that this wget is going to run every single second, and it's going to give me the output on this screen, and it's going to show me which server it is. So when this new server spins up, right, you'll be able to see that new server is coming up over here, and this actually goes up and tells you that the content is served from the new server, like manage server 3, 4, 5. Likewise, it's going to come. So that's kind of a identification what we're going to see for the setup to work. So we have done everything correctly. If we have done everything correctly, this is going to work like a charm. So let's execute this, see how it works as of now. So it says an exception over here. It says connection refused. To do export. Yeah, now let's see. Okay, so now you can see that I'm accessing it. A new pod has created here, load generator pod. You can actually see, let me decrease the font size. You can see that this is coming from manage server 2, manage server 1, manage server 2. Likewise, it just keeps changing, okay? So every second it's going to update us on which manage server it is coming from. So I'm just going to keep that over there so that we get the maximum information and see that whichever server is serving the request right now. So when you scale up, it's going to be useful for us. We are going to see that output as well. Now to scale up, you have to use the command kubectl scale. So this is the option under kubectl. And then here, this option has another option over here, replicas. This is a standard option. So we do this in terms of deployments, replica sets. So this is a scale option would work, but you have to combine this scale option replicas with what you're planning to do. For example, in this scenario, I want to use this scale to five replicas for my cluster. Okay, so only clusters, replica set, and deployments can use the scale option. Domains cannot use. So do remember that only cluster and other things which I just told you is useful. So you have to give cluster.weblogic.oracle / the name of the cluster. So this is the criteria, and this is on the namespace. Do not forget the namespace, because this particular item is not on the default namespace. So when you don't give any namespace parameter, it goes to the default namespace and says that, oh, there's nothing in this name. So you have to say that, okay, look for this object in this namespace. So that's the reason why we give this. So just give enter, and you should see that the new servers are getting created, initialized, and then get to the running state. So till now, you get 1 and 2. And if I just check the description of the service, I don't see the new service being added because it has not come to the ready state. So once it comes to the ready state, then you will see the new endpoints being added over here, and you will start seeing the server populating and receiving content from 345. Let's give it some time because WebLogic would take some time to start up. So once it goes to ready state, then I'll run this command and you will see the cluster service, including the other members, which is newly created, the managed server 3, 4, and 5. If you see WebLogic service over here, currently it is listing, but this should change in a moment. So it's still coming to the ready state. So now one server came to ready state and you can see the new server being added over here, and slowly other two servers would come and you will start seeing managed server 4. So you were able to see managed server 4 over here as well. So you saw that managed server 4 coming through because that server was ready. So you can see that again came through. So other servers are getting started. So let's keep verifying. Now, after this completion, we will be talking about auto scaling. So right now we are manually scaling this up and down. But what if I want to do automatically? Like, for example, when my CPU utilization goes up, then I want new members to join the cluster. When it goes down, I want it to reduce the number of members. So we will be talking about that as well. So here you can see that the restart has gone 1 because it didn't come up in the specified timelines. So this could be, the delay. So whenever the managed server goes, takes time to start up, the liveness probe restarts it because it didn't come up on a time frame. Now this could be because we are running on a low memory system. So when you are running on 8 GB, it's not enough for the system because the worker 1 and worker 2 is the one which is actually hosting these content. So you can see that the load becomes high on the system. The managed server becomes slower to start up. So this is the issue why the server is not coming up on time and the liveness probe restarts. So this means that you need more memory on the system for the JVMs to start up. So if I just abandon the system and go for the next level or the, type of system, I need to go for 16 GB of RAM because it doesn't have enough memory for it to come up or the time frame for it to wait as well. I can see that the restart has become 2. So we have to give it some time for the JVMs to come back up. Canceling the script would actually help for the JVMs to come back up because this puts load on the system and that eventually creates memory issue. As the memory on these servers will be like little high. So if you just verify the memories, right, or the top utilization of the process, you can see free-m. You can see enough memory is there on this 232 system, but still the CPU utilization would have been like high enough. So that must be the reason why this could have, delay the startup over here. So let's just check the logs over here. Group control, logs. Pod name, -n, namespace name. So you can see that the server JVM is starting. You see that it's coming up. So this, having stopped the script from running will reduce the memory utilization and the CPU utilization of processing the website continuously. So this would give some time for the server JVM to start up. So you can see that it is coming to the starting state. Now it has come to the running state right now. So the JVM has started running. So you can see that it came up fine. Now, how it came up fine? Because I stopped this script because the script was taking so much memory that it was not able to, bring up the JVMs and dedicate the memory to it because these servers has only 8 GB. We are running T2 large. It needs X large. So now if you just go back over here and do a refresh over here or just click on the server, you can see all the servers are running over here. And in terms of your application description over here on your service, you can see that +2 more. So it tells you that there are a lot of endpoints over here and you will see managed server 1, managed server 2, managed server 3, managed server 4. managed server 5 as well. So you can see all managed server is serving request over here, and it's all working together to serve your request. On the next video, on this training, we will be working on how to scale this autonomously without our intervention. What we will do is we'll go back to, scaling our servers to back to. And what we will do in this situation is that we will be increasing the load on the system, and then we will autonomously create pods to serve the request, or to serve because like one of the pod is having maximum memory utilization, and it basically spins up, and it basically reduces and increases the number of servers when there is any issue detected. So now we have executed replicas S2. So now what it's going to do is it's going to scale down the servers, but it's going to take some time to scale down, but eventually it would, once I do a control C on the script, because it will see that there are people using this. So it won't actually scale down. But once I stop the script, you will see that it gradually comes down. So here I'm deleting this particular pod, which is created by me. So this is because I did a control C early. So that's the reason why I'm removing it manually. So I'll put this script also as part of your document, so do not worry about it. And everything is going to be covered as part of this training. So nothing is going to be left out. Thank you again for watching this video. Slowly, each one by one service will be suspended, and then it will be shut down. It will do one by one. So you will have to check it after some time. You will see only 2 pods running. The server 1 and the server 2 pod will be the only pod which is running. Thank you again for watching this video. I'll see you on the next one.